Hi, we are going to look at how the cube roots and square roots make sense. So if you look at a line, so let's say this is 11 meters and forget about the meters, let's say it's 11, something like an A or X, Y, something like that. Now, so you want to look at that with the square like this. Each side is equal. So let's say side A times side A will get you the area, which is capital A, right? Now, if you look at a box, a cube, the cube has three sides, right? So that's A. Other than the A squared on the top, we have extra ones, right? So therefore, that's A, that's cube, that's actually volume, right? So that's A to the power of 3. So that kind of the relationship we want to look at, a line, a square, and a cube in order to understand these math you will be dealing with. And also we want to look at, if you look at the back side of this cube, like the blue shade is one area, and then the front side of the cube is another area. It's 1 plus 1, two areas. And then if you look at the other four sides in green, right, and left, right, top, bottom, and that would be four sides, total of six sides. And these six sides of A, the area, will give you the surface area. Now you can imagine why we are dealing with these binomials and polynomials and different values, right? So that's what you want to connect the dot. If you are a DAT, MCAT, that type of exam taker, test taker, and then you have to connect the dots, right? So so that's the value of these type of numbers. Okay, so we look at some more. So the square is a square, right? And the cube is a to the power of 3 cube, right? And then you can have more coefficient values depending on how many areas you're counting, right? Okay, now from that we can also kind of get the idea. Let's say any number, few numbers, you can go 1, 2, 3, and then all the way up to, let's say, n. And then we can sort of have to look at x is, let's say 1 is actually 1 to the power, 2 is 1 to the power of its own, 3 is 1 to the power of its own, and n is 1 to the power of its own, right? And if any of these have the zeroth power, they will automatically become 1, right? Any value, any number has the zeroth power, that will become 1. So that's something we want to understand. Okay, and also if you look at minus x to the power of 0, that power of 0 is 1, so the minus 1 still stay there, right? So that's another difference. So the minus 1 stay, and then x to the 0 becomes 1. So that's why 1 times minus 1, that is minus 1. That's what it is. Okay, now we also want to look at this way. The numbers are like x to the 0th power, x to the 1, and x to the 0 is 1, right? And x to the 1 power is x to the 2 power is x squared, and x cubed, and x to the 4th power, and so on. We can go on, right? So they can be written like that. Now we also want to look at the negative values, right? So if I get x to the power of minus 1, x to the power of minus 2, that is basically, we can x to the power of minus n, let's say any number, that would be actually 1. Yes, divided by, it's 1 divided by x, right? 1 divided by x to the squared, and so on. So that relationship, we have to try to see that. Okay, now also we can look at few um, square roots, how to find it. Okay, and also I will do some cube root findings, and also to do the math without without a calculator, right? So these things, if you can remember, that would be a good idea. So 1 to 10 actually, right? And it's something like this one. So the x to the x squared is 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and 8 squared is 64, and 9 squared is 81, and 10 squared is 100 actually, right? So it's good to know this way. Now we also want to know uh, to the power of 3, right? X cubed. So 1 cubed is 1, and 2 cubed is 8, and 3 cubed is 27, and 4 cubed is 64, 5 cubed is 125, and so on, and then 9 cubed is 729. So you kind of want to write these ones in an order, in a meaningful way, so you can use it when you solve problems without a calculator, right? Now the other relationship, so these are the power, right? The 3 to the power of 3 is 27, 3 to the power of 2 is 9, right? Now we can go backward, so 64 back to the fourth. So that's coming from cube root. So the 64, and also the 16 going back to 4 is square root. So we'll write that relationship also, so you can see that in one page. So 16 to the square root is 4, and 64 to the cube root is 4, right? So that relationship when you go backward. Then also we can write 64 as the 1 divided by 3, and also we can write 16 1 divided by 2, right? Okay, so that's another way of writing it. So we're going to look at few other calculations. Let's look at how do we deal with the perfect squares, right? So the dealing with the perfect squares is actually easier, and mostly we can handle without a calculator. So now we know perfect squares of 1 is 1 squared is 1, and 2 4 2 to the square is 4, and so on, right? And let's look at how to look at the roots, right? So to get the roots, let's look at this way. 36, root of 36, we can divide the 36 2 by 18, right? And then the 18 is 2 times 9, and 9 is actually 3 times 3. Now we can write it as roots, right? Because we are looking for 36 root, so therefore there's 2 to the power 2 and 3 to the power 2. Then the root to the squared cancels out. You left with 2 times 3, which is 6. So that's how you get the root of 36 as 6. Let's try this one a little bit harder, 196. So 196 is 2 times 98, and the 98 is 2 times 49, and the 49 is 7 times 7. Now we can write that one. Root of the 196 is equal to root of the 2 and the root of the 7. And then we can cancel the square to the root, right? And these two cancels out. You're going to get 14 is root of the 196, right? So that's how you kind of want to see the relationship. Not to memorize, right? And look at 400. This is much easier. So it's 4 times 100, then 100 is 4 times 25, and 25 is 5 times 5. We can write root of 400 as root of 4 and root of 5, and there's two pieces, so squared and squared, they cancel out. So the root of 400 is actually 20, right? So that's how we want to um, work with them. Now we can get a bigger number too, but I mean, it's not that much helpful. I mean, it's hard to do this kind of math without a calculator, but just let's look at now you have a calculator, right? So 5625 is 5 times 1125, and that one is 5 times 225, and that's you're getting from 5 times 45, right? And then the 45 is 5 times 9, 9 is 3 times 3. Now we can write this one. So square root of 5625 should be equal to the root of 5, another root of 5 squared, another root of 3 squared. Right now the square to the power cancels out, so you left with 5 times 5 times 3, which is 75. And then you can plug into a calculator and check it out. So that's how we deal with the perfect squares.